Hi guys, welcome to my channel today. Today I will be discussing a topic wherein build cost-efficient Azure ML Designer pipelines using Gemini Pro API optimization. So I would just keep it simple. The reason I chose this to do with Gemini API is I want to integrate an LLM tool to optimize my Azure ML pipeline. We know that it takes a bit of time to even train your machine learning model and to get the optimized hyper parameters, right? Even for the pipeline. So, in order to avoid the pain of going through multiple iterations and the time you spent, it's better you make use of the LLM tool, which actually works for you to determine those optimized parameters. Thus, it helps you to make your pipeline more efficient, right? And even if the data is large, it doesn't matter. Like you are still able to take the help of an assistant to improve on your pipeline, machine learning pipeline, which you create. So it's the best part about it is you just not improve your machine learning pipeline. You also avoid the compute cost. So the prerequisite for this video is before I move forward is you should have a good understanding of Azure ML Studio. I have it because I have already completed a certification Azure DP100 with new designer data science solution. So I'll go through these steps. I'll go slowly, and if you need to pause the video to understand things, please do so. Because this will take you a bit of time as it takes me time as well. It's not like I'm gonna write the perfect code in the first attempt. It does take a bit of effort. So as you move forward, if you really like what I do, and if you think I do help people by sharing the knowledge, please do subscribe to my channel and please like the video as well. That helps me to make more videos of this type wherein I share my knowledge about ML as well as data engineering, which I think is a hot topic for 2026. And I also enjoy doing it. So let's move on to the main part of the code, wherein we will see how we can actually make changes. So it will just not be a code part. It will include Azure understanding of Azure ML Studio, as well as Jupyter notebooks, as well as using the Claude tool AI assistant um, to generate those scripts. And like it's I want to be as efficient as we can because we need to reduce our time for writing code. And that's can really help you do things better, even while designing the production grade pipelines. So let's get started. So the first thing you need to do is you need to have an Azure free account. As you can see, I do have few credits, right? So you can do the same, and it doesn't take a long time to create your Azure account. So first thing you need to do is the reason where I got stuck today was I was trying to create this Azure ML Studio, this resource group, but I wasn't able to do so through the Azure portal here. So what I found out was there was some issue with I think the way you select your locate your server, right? So that was an issue. So I chose to do it other way. I went to Microsoft Foundry Azure Machine Learning. From here in as well, you can create. So if you go to the home, right, you can create a new workspace for yourself. Currently, I have Dash Azure ML. So I think it's pretty vast, but again, I would just stick to what I am focused on to make use of Gemini API or Gemini Pro, which is absolutely free. Anyone can do it with a Google account. You can make use of that LLM tool to make your machine learning pipeline efficient and avoid compute cost, which again is a huge advantage when you don't have to go to multiple iterations to get the optimized parameters. And it does require an understanding of what a Jupyter Notebook is, how you can create a notebook in Azure ML Studio. So there was again a bottleneck. I was trying to create a notebook from in here, but then I found out like they have changed it. So what you do is first you go into compute, then you can create a new compute. For example, I'll just show how you can create a new compute. I'm just using the basic compute. I mean, instead of having high-end computes, right, which really cost a lot, you can make use of LLM tool to save on cost as well as on time. I use the first one, which is pretty cheap, and this is the compute. And then what I did was I started the compute. Then you can go into JupyterLab in here, right, where you can see you can select the different kernels. So I chose this Python 3.10 SDK version 2 um, because I that's suitable for the task which I'm doing. You can know more about them on respective AI assistants like ChatGPT or Claude, wherever you want to know, and the other things as well. So it's a bit of for you to explore, um, and I feel like there is a lot of things. Even if there are so many components to it, but I would just focus on the tools which really help you to do things, and it will take you some time to even explore and understand things. So it's fine, as long as get onto the right track. And so what I would do, and before we move forward, the things which I'm actually doing, I would show you. So this is the cloud, right? So what I am trying to do today is this. So what I'm doing is I'm connected to an Azure ML Workspace, which has a server somewhere in south of India. I tried locating US East, but it didn't work out. So yeah, then I have my Gemini API key, which is like an LLM tool, right? Everyone is aware of Gemini, but I want to use it for myself to train an ML model and generate the optimized parameters. And this solution can be used for complex problem as well, not just for a simple problem. So because I was thinking about it, like how can not in surface level video, wherein I can actually tell people what how you can be efficient, right? And the main cost is through the compute, and if you can avoid that and save your time, why not? Then I have my scripts, which I will show you soon. So what I do is I also generate a data set, time series data set. So I was trying to do time series forecasting, but again, it's more so on utilizing the right tools, not deep diving into what time series is, because again, there are so many things into time series. I would not go deep dive into those tools. And so what I'm doing in pipeline is I'm preparing the data, then I'm splitting it 80-20 split. I know most of the people who do machine learning, they are across that you need a training data set and testing data set. Then you use the Gemini optimizer based on your prompt. It will tell you what to do, right? And it will just help you train the model and get the right model for it, and then the model output. And then you register that model, right? Yeah. So what we do is leave this for here, and I am actually doing all these things in VS Code. So again, this part of VS Code is what I've done in VS Code is I have actually connected, for example, from extensions. You can download the Azure Machine Learning, and from there on, what you can do is you can, let me show you, right? This is already connected. So, all right, I'll show you why I use VS Code, because there is a direct integration available with the compute instance available on the Azure ML Workspace, and you can directly connect your VS Code with using the extension and directly run the code in your VS Code editor, and you don't need to go back in here, to do all these things. Let me just show you, right? So because here also you can see the notebooks, right? For example, this notebook exists in here, right? So you can see the notebook here, create notebook. I'm not sure why isn't it working, but again, you have to find a workaround. Maybe it's a free tier account. They might have certain limitations based on the location. So yeah, as you can see, I have different folders, right? Model output, optimize parameters, train, and the data set. I'm gonna rerun this notebook. So I have this subscription, my resource group, workspace, and region. So yeah, I already ran. You need to connect to your Azure ML Workspace. So what you are doing is you are importing this available ML client, which is the machine learning client. And based on this, you first get, based on a subscription ID, resource group name, and workspace name, you get the respective details, what is the current workspace name, location, and resource group. And then you have your Gemini API key. So I already ran this. So then the next step, what you need to do is you need to generate and register the data set. So this is a random function which is used for each date range to generate the energy time series data set. I wanted to use from an open source. Maybe that's for the other time. It doesn't matter, right? As long as you are able to save that data into the data set. I'll show you what data set is. So what you actually do is you can do two ways. Can you say there are two versions of it? So you can either register it manually, which I would avoid, because if you need to have different versions, right? And the whole point of using LLM tool and Cloud and all those things is to avoid the manual intervention, to design automated pipelines, so that you do not have to, as long as your pipeline works. So this is different from your data pipeline. It is a machine learning pipeline, so there will be transformations involved and everything involved. So I'll run this again. So it ran in 7.6 seconds. So I have registered the data set as well. Now it is again time series, and you can see when I refresh this one, right? You will see there is a new version of energy time series, right? And what I'm gonna do is, yeah. So I'm gonna see that, like, in a few full time series daily energy consumption, as you can see, there is a trend in energy megawatts. 2018, 2019, 2020, 2021, 22, 23, 24, right? Monthly average. Um, and you can see the mean energy consumption is, I think it's in megawatts, right? And yeah, and the minimum is this, standard deviation is this, 25 percentile is like the records which are under 25%, 50%, 75% max, right? Now what we do is we create a pipeline component. So what we have three components. We prepare the data, we optimize it, and then we train it, right? So three different Python scripts. So it's not something you can do in first attempt. Just a bit of I wanted to let my viewers know that you need a bit of practice to even understand what's happening in the code. I will put this code on my GitHub repo and also share in the video description. Maybe you can use this for understanding. Maybe it's not a perfect code, maybe it is. So maybe just focus on understanding the different components and how the pipelines behave. How am I using the multiple tools to actually create an automated machine learning pipeline to have an optimized parameters using LLM, right? So preparation script. So this is all Python script I put in this, and then you have the optimize script. So yeah, I mean, you need to understand pandas. I mean, you need to have a good understanding of Python, which will really help. So what am I doing is I'm using the API key for Gemini, and I'm passing a prompt, right? I'm an expert ML engineer optimizing a time series pipeline, right? So based on that, it will generate a response, and then based on that, I'll get what am I gonna get from this? What I'm going to get is the optimized parameters, right? Based on I need to know what number of estimators I need, what is the maximum depth, what is the learning rate, forecast horizon, lag features, rolling windows list. So and it will also have an understanding of my data set. So based on that, it will actually let me know. Yeah. So and it will save it, make directories, optimize parameters exist, okay, true with open, it will save those parameters in a directory. I'll show you the directory as well. Then you use the train .py script. Yeah, yeah. Let's run this code. So the scripts are ready. Now the final part wherein you actually build and submit the pipeline. So what I would recommend is try going through each step and slowly, because it took me an entire day to prepare the script. I wouldn't lie, it has taken a bit of time to optimize the code, prepare an automated pipeline which works smoothly, Um, and yeah, so let us Gemini component. Gemini is optimizing it. We are preparing the data, right? And then based on the optimized parameters, we define the pipeline, right? So yeah, and then we fetch the data set. Let's run this. Yes. Uploading prep. So the reason I can read on this job is I'm using a random function. So each time you will have different data, right? So based on that, you will have different parameters chosen for it, because if the mean and variance is changing, I mean, your other parameters would change as well. So it ran quite smoothly. Let us see, monitoring of your pipeline. You can also see the web view in here, right? So I want to integrate the components in a way wherein you can see all of the things, and it is kind of helpful, right? Wherein you do not have to a lot of stuff for different components at different place. So can you see this? I wanted to do it very manually, wherein I have everything, designer doing everything on its own. But then I thought of like, can you see the steps involved? You have this CSV data set, then you prepare the data set, then you train it, right? Train forecasting model, and you have the train data, which is going to the Gemini Pro parameter optimizer, right? Based on the optimized parameters, you feed into the train forecasting model, and then you have the model output, right? So this is really cool, right? I please guys, if you think that this looks cool and it can really help you understanding the different components, please do comment on the video as well. And if you are stuck at any place, I would try to help you out by answering to your comments. So I hope, and let's go back to our, and then what you can do, I think it's still monitoring the pipeline. So let it run. Submitting first runs, first files are this, and it does consume compute. So your compute, I'm using the most basic compute. I didn't want to use the high-end compute and paying a lot of for it. So streaming pipeline logs. What is happening in here? So which I think it's stuck at this stage, right? You can see what at what stage what is being happening, right? So currently you are at the preparing the time series dataset. So at each step, you can see it happening, right? So let it run. And in the meantime, I can show you something in here. Compute. So this is JupyterLab or maybe a notebook. So you can see, right? Model output. No, this is your optimized parameters. Parameters. There's a JSON file, right? You can see the JSON file. That's how you save your model parameters. You know, the optimized parameters each time. This is the model file, saved model file. Yeah. I optimize parameter train. This is your data set. Let us see at what step it is. It is taking a bit of time. It is fine. That's the reason I wanted to show how it works, so that it is helpful in some way, not just theoretical content, which I would absolutely avoid, because there's so much of I mean, theory is all around. I wanted to show where you actually fail, what are the actual like pain issues while creating an ML pipeline, and how you can avoid, like you can utilize the time and improve your efficiency while designing a pipeline. Let us click on this. What is happening in here? So view definition, view log. So view jobs. Let's see view jobs. What is it? So there's an experimental code running. So this is run. This is done. Let us see whether it is completed in here. It has ran. Now we are on to, it's like based on your data, trained data, it is getting the optimized parameters from Gemini Pro model. Yeah, it's absolutely free. You can make use of it and understand how you can actually use an LLM tool to optimize and improve the efficiency of your ML pipeline in the Azure ML studio. It can be like other studios as well. AWS, I'm not sure about AWS. I'm not using it, but again, I found it to be a bit relevant from the Azure. So it has failed. Not I no idea why it has failed. Let's see. Why did it fail though? Maybe it already has the parameters, so it's fine. It did fail. So what happens if it fails? Let's go back. So it says it has failed, right? So yeah, it has failed. Completing execution of experiment failed. So failed at the Gemini Pro step, right? Yeah. So if I try to register and train the model, does it work? Not sure. So it will fail as well. So what? So my monitor pipeline job failed. Let's go to Claude and tell him my monitor job failed. The pipeline cell failed due to Gemini Pro something. What can be done? Is it due to I already ran the Gemini Pro on the in the previous Gemini Pro in the notebook to get the optimized parameters. Get the optimized parameters. Optimized parameters. Yeah, I think failures are inherent part of your. So what does it say? All right, it says so it says use this. Am I using this? Am I using this? Let us see. It is being used in here, right? Rerun this. I will rerun this again. It will again do it. So this is a designer, right? It failed on that step earlier, right? So can you see it failed earlier, right? I hope this works this time because I tried to use a different it's free, fast, and currently active. Maybe the old API for Gemini Pro might have some issue, right? It has failed again. Let us see why has it failed. View log. Let us see the log part. What I'll do is I'll copy this. So I'll go in here. This is what I got from the log. Got from the log. So what I would do is I would ask it to come back here. Can you rewrite the whole script in here, right? I need to update the optimize.py, train.py. I'll ask it to update everything. Can you change? Can you make change? Can you update the optimize.py script? Py script. Yes, that. So what I would do is I would use this. So this is our real-time failures. That's what happens. So, I mean, again, but you need to still do it, right? You can't just leave it for as it is. What the heck? Not leave them for as it is. You still need to do everything. Let's copy this again. Yep, and let's run this again because I want to. I mean, it's fine, It's not gonna be perfect in the first attempt, but again, I just wanted to show how can you use multiple tools, optimize the ML pipeline. I know and you can see again. So let's see, this should work this time. So let us see whether it works this time. If it does, then it shows. But if it doesn't, then I will again try to improve that script. But again, it's like you try multiple times. So, and that's how you improve your understanding of how you can optimize your ML pipelines. Yes, it's gonna work this time. Yeah. So if I'm not getting any optimized parameters, I'm just gonna use the default parameters. If I'm getting any optimized parameters, yep, perfect. Then it's gonna now move on to the next step. Yep, yep, training the forecasting model, which looks cool, right? Because I'm trying to use multiple tools. I wouldn't say that. I mean, most of my videos aren't at the introductory level. Yeah, I start from the introductory level. Again, I reiterate this in every video because I just because these sort of videos don't exist. I mean, you can have like I mean, I might have seen wherein you will have some part of it and the other part is missing, which is pretty annoying. And I actually want to I actually want to do a better job while even doing the video. So it's actually they're doing the same thing. You can see the web view of it, right? So it is very cool, right? Just using the VS Code, you are running your pipeline. It also corresponds to the same thing, I guess. So, yep. And again, if you really think, guys, like this video has a bit of value to it, please consider subscribing my channel and liking my video and also commenting because it really helps me, motivates me to share more knowledge and work on it. Uh, yeah. So let's go back to VS Code. It's still running. I think I can still go to the registration model. It shows that maybe there is a model parameters which are being saved, right? That might be still being under the process. But again, I can still run yeah, I'm streaming the live logs, checking the final status. So, all right, let's register the trained model. I want to see this. You can't actually unless you have something on the output path. Yeah. How long does monitor pipeline job takes? Let's ask. How long does monitor pipeline cell takes? And can I register the model while that cell is running? That cell is running. So So it will take a bit of time to run. But again, yeah. So in the meantime, what I can show you is it is still running. It's going to take about 10 minutes or something. And this is again a registered models. That's the last step. This can still run, I guess, because, but that is busy. I can still run. This is just to show the data assets in your workspace and the registered models and the data stores. So I think this is a pretty good workbook. This Python notebook. I'll do share it on my GitHub repo. And I guess can I push it to GitHub repo? I can, but I have to connect my Azure to my GitHub repo. That I'll do. I think it won't be very difficult, but that's not something part of this video. It did fail at some point of time. But the run is still executing on the computer target. Details for cancelling the run can be found here. There is something happened, right? Streaming for the run interrupted. So there is something, but it's fine. What is it saying? Let us ask this. What does this mean? What does this mean? So I can use this to check whether what's the issue. So I kind of like using these LLM tools. These are pretty cool. It has already completed, so I can easily run this one. Yeah. So I've successfully registered the model, a new version of the model with the new parameters. So this is V1, right? Again, I'll run this because I kind of understand this. So yeah. So can you see the registered models version none? V1, yeah. So the jobs which have failed and which have executed, right? So these are the jobs, and these are also visible in here. So you can see the line of jobs which have failed and which have. So are these all jobs, right? I want to see all jobs. So these are the jobs which have failed. It has completed, right? And yeah, so it looks cool, right? I'm not models. Let us see. Is there any model? Yeah, this model has been registered now. So you can serve this model, use this model. Let us see. It has only one version, right? And endpoints. There's no deployed endpoint. I think that is for a different video. So my whole point was can I use an LLM tool to get the optimized parameters, and I am able to do so. And maybe in the next video I can serve this model and use it on a batch of data to understand monitoring. So I haven't used anything in monitoring. So I guess that should be all for this video. And if you guys think this video really helps, so and if you and I'll share the GitHub repo as well as the other details how you can as well as the steps what I did while preparing this notebook. So and how so that it helps you understand more. And so that it's just not an introductory level video, and it does have some content as well as not content, I would say some sort of learning to it. So basically this tutorial can really help for the people who are preparing for Azure DP 100, which I already gave in the past. So yeah, so that's something I would like to end my video with. And before we go, yeah, so thank you guys for watching it. Thank you.